Look down at the Earth from orbit, and your eyes are naturally drawn to this massive white ridge scarring the surface. We're descending towards southern Asia, a place where these towering, snow-capped borders dictate the daily lives of over 1 billion people. At the heart of this region is India, the 7th largest country by land area. Geography, however, ignores political lines. India anchors a distinct landmass known as the Indian subcontinent, a sprawling geographic zone separated from the rest of Asia by its own mountain borders. This subcontinent spans an incredible scale, shared today by a tight grouping of neighboring nations: Pakistan, Nepal, Bhutan, Bangladesh, Sri Lanka, as well as Myanmar. This sprawling, isolated landmass was not always here. The borders that define it today were formed when one continent crashed into another, physically forcing the Earth's crust into the sky. Rewind 50 million years. The Indian plate was an island, detached from Asia. It moved northward at a rapid geological pace, crossing the ancient Tethys Sea. Eventually, that ocean closed. The Indian landmass slammed directly into the massive Eurasian plate. Because the Earth's crust is broken into moving tectonic plates, a collision of this magnitude has nowhere to go but up. As India pushed against Eurasia, the land between them squeezed, crumpled, and folded upward into the sky. That geological engine never actually stopped. India is still pushing into Asia today, advancing at about 5 centimeters a year. Consequently, the Himalayas are still growing taller by a few millimeters every single year. This ongoing collision created a multi-layered geographic machine that dictates the region's diverse ecosystems. To see how this machine works, we have to travel down its side. At the very top, in the northernmost layer, lies the Himadri, or the Greater Himalayas. This is a zone of extreme altitude and perpetual year-round ice. The scale here pushes the physical limits of the planet's atmosphere. The Himadri is home to a group of peaks known as the 8,000ers, mountains towering over 8,000 meters high, including the peak of Mount Everest. This freezing environment serves a critical purpose. The deep valleys catch precipitation and compress it into massive glaciers, like the Gangotri, locking up vast reserves of frozen freshwater. As we drop south and lose a few thousand meters in altitude, the terrain completely flips. We enter the Himachal, or Lesser Himalayas. The crushing ice gives way to lush, temperate valleys and dense forests. Because the climate here is moderate and favorable, it supports abundant life. Dense, colorful human settlements and hill stations, like Shimla, are built directly into the steep green hillsides. Continuing our descent, we reach the lowest, southmost layer, the Shivalik, or Outer Himalayas. These are rolling, densely forested foothills built from loose sediments, acting as the final physical transition zone before the land flattens out entirely. Within this single mountain range, altitude alone dictates exactly where forests take root, where the snow never melts, and where humans can comfortably live. Geography rarely offers a smooth transition from ice to forest. If we move to the northernmost part of the country, into Ladakh, the lush valleys disappear into a high, rugged expanse of bare rock. Ladakh is a cold desert. During the winter, temperatures plummet to 30 degrees below 0 Celsius, yet the region receives almost zero rainfall. Surviving in this harsh, isolated environment requires intense adaptation. The people of Ladakh have built an entire culture suited to the arid conditions, erecting striking structures like the Hemis Monastery straight out of the barren stone. Ladakh looks this way because the massive peaks of the Greater Himalayas act as a physical wall, blocking moisture-heavy rain clouds from ever reaching it. Pulling back out to a macro perspective, we can see the true value of the Himalayas. We have to look past what these mountains are and examine what they actually do. They function as a continent-sized shield. During the winter, brutal, freezing winds sweep down from Central Asia. The Himalayas physically block those currents, preventing them from destroying the warm, temperate climate of the northern plains. In the summer, the effect reverses. When moisture-heavy monsoon winds push up from the Indian Ocean, the mountains trap them. Instead of escaping north, the clouds are forced to release heavy, sustaining rains over the subcontinent. This combination of summer ice and rain earns the Himalayas the title of the Water Tower of Asia. They feed massive river systems, like the Ganga and the Indus. As these rivers flow south, they carry vital water and rich alluvial soil to the flatlands. This river network supports the agriculture, transportation, and daily lives of hundreds of millions of people. Without that tectonic impact, if that prehistoric island had never crossed the Tethys Sea, the rivers, the climate, and the very foundation of South Asian life would simply not exist.